function is an object in itself, it can be treated just like any other object. It can be returned from the function. Okay, so instead of returning a call, like you see in the slides, I did like this, right? So what's happening when we do this? This is a variable name that points to the function object, and then when we precede the name by round parentheses, it means that we are calling the function for execution. Okay, so what's happening here when I do something like this, this function will be executed, and what returns from the function is what will be sent as the return from the outer function. Okay, but now I don't want to call the function for execution and return a result. I want to return the function itself. So how do I return the function itself? Just by using the name of the function without parentheses. Okay, so that name just points to the function object. It will return the function definition. Okay, so when we go outside here, what we receive when we say raised to power of 3 is actually a function. It's not a value. I mean, it's a value, but it's a value of object of function. So we can receive it as cubic function. All right. And then in order for this function to be executed, I can use the name of the variable and then precede it with the round parentheses. So I want 5 to be raised to 3. So that's what we want to send. So you see this, we have a function object at this moment. When we execute this, we would have a function object, okay, that has something called value, and it would know from the outer it consists that there's something called power, and this is a function object. So let's say this is a memory location 1, 2. When we define this object inside the inner function, there was a variable that pointed at this object, and we use it to execute it, right? Now, when we return something, we return the value, not the variable, right? So when we return the reference to that function object. So outside, when we have this, if you're gonna call it cubic function, it will have the same reference. So when we want this definition to be executed, we can use either this name or this name, depending on which of them is accessible in the scope. Okay? So if we say helper, and then in round parentheses, we call it for execution. It is exactly the same if we say cubic function, and then followed by parentheses, we call it for execution. We are, in both cases, we are talking about the same function object. Okay? All right, so let's try that. I'm gonna run this in debug mode, and we step inside. Now we are about to call the raise to power with a value 3. Okay, I'm going to step inside. The helper was not defined yet. A new object will be created every time we call raise to power. This object, when it was created, power was equal to 3. Okay? So we create the object, It's just the function, there is a code that defined, but nobody called it for the execution. It's just a definition. Now we are about to return. What is returning here is the object of the function itself. All right, now we are about to exit here. Raised to power is about to be discarded, and everything inside of it will disappear, so including the power. So now I am back to the module. We don't know anything about something called power, right? Nothing. This is what the memory knows so far. We don't know anything about anything called power, except when we execute the function that just returned. You see here, this function that came from the raised to power, the function that just came, the function variable that we just defined here, the cubic function, has a pointer to the object that was defined inside the raised to power. Now we're gonna execute it, so I'm gonna step inside of it, hopefully. Yeah. It still remembers there was something called power, and that power was equal to 3. Okay? Even though the raised to power itself is discarded, but helper, the inner function, remembered the variables it took from the outer function. All right, and now it still remembers that the power was equal to 3, so we can raise the 5 to 3 to the power of 3, and then return the result. Okay, so now we will be back to the script, which will print 125. Okay, let me just remove this altogether. All right, now I can use the is pointing. It's not pointing to the. Say that again. Put a function inside of the function. We'll remember the local variables that were defined in the outer function. I'm not going to point to it. Just remember the variables. On the board, that points the address of this function. Not the outer function. Okay. All right, let's try to raise something else to power of 3. So let's say that we want to raise 10 to the power of 3. We don't have to call the raised to power again, because this what came in this cubic function, the object of the cubic function knows that power is equal to 3. So we don't have to keep redefining. We just use this function, and it internally it knows that there is power is equal to 3. So let's say I'm gonna raise 10 to the power of 3. I'm gonna run this. And step inside. It still knows that power equal to 3. Okay, so it's part of the object now. Okay, now if we step outside this, it's gonna print 1000. Okay, now what if I want something to raise anything to the power of 2? Okay, so I'll call it square function. So I can call the raise to power and give it 2, so that will return the helper definition that remembers that power is equal to 2. And I'm just gonna raise to power also 5 and 10. but using the square function instead of using the cubic function. Okay, so I'm gonna go there. Well, step inside. Now we're calling the raised to power again. That new object that will be created is different than the object that was created when power was equal to 3. It's a completely new object is created for this function definition. All right. When this object was created, power was equal to 2. So now we create it and we return it. When we try to execute it, it will always remember that power was equal to 2. So now it's raising 5 to the power of 2. All right. So it will print 25. And again, if we try to step inside it, so it's this function object always remembers that the power was equal to 2. Okay. So this concept that we have been describing is called the closure concept. And that concept exists in other languages like JavaScript as well. Similarly, like there's some differences, but it's very similar. When we say that the function object remembers the local variables of the outer function, even though the outer function itself is not in memory, that's what we call the closure. Yes.
Does the I'm confused why the cubic function pointed to helper function? Is it because raised to power has a return value of helper?
Has returned the reference. So when you return something here, you return the value inside that variable, right? Yeah, the address. Yeah, return the address.
So cubic function was raised to power, but raised to power has a return value of helper. So it's pointing to same thing like helper.
Oh, equal. You see, equal. This equal. When we call the function with round parentheses, we are calling it for execution, right?
Yeah.
So when we say square function equal raised to power, but the raised to power this is a call for execution. So what what returns from the function will be assigned to the square function. Okay, so the raised to power will be executed, and internally it defines a function object with an address in the memory. And then here at this line and this line, so here we are calling the function for execution, right?
Yeah.
So this the code inside would be creating the object that currently referred to with a variable power.
Yeah.
But this variable has what is stored inside is an object. Now here we are using the function a that was telling what is stored inside the function. So what's returning? So when you before you do the assignment, you just have to finish the evaluating this part. The evaluation of the function call is what returns. What returns is the address of the power helper object, right?
Yeah.
So now what square function is the object is containing the function.
The return result happens before the where the result.
This line is just a definition of the line. This is not executed unless we call the function to for execution.
Oh.
So there is a return line here, but this line is not executed until we call the execution. Now, what happens every time we call raise to power, we create a new function object. So there's a new function object every time we call raise to power. And that's why we can have different functions coming here. So this time, this object, the object that returns from this call, remembers the power is equal. The object that comes from this call remembers the okay. All right.